Plan to do is this. So plan. So you had 3 questions, a little bit more, but relatively easier questions than the others. So as far as I saw, most of you got the stuff right. So what I would like to do is just go over quickly over the questions. Go over questions. And then see if we can collectively give feedback to one of your work. So I'm going to maybe take Sam's work and see if we can give him feedback, okay? Feedback. That's okay, Sam.
Yeah, no, that's fine.
And then what I want to do is I want to throw a question at you and see how you go about solving it. Okay, so I'll give you a question that you haven't quite seen before and see how well you can do on that. So then, new question. Okay, so let's start with this. First one here. So household is a weekly disposable income of 100, consumes only sausages and potatoes, X, Y, sausages cost, PX is 4, PY is 2. The government is concerned about the household's diet, provides a really weekly allocation of 5 kilograms of potato. So X star, let's say, Y star is equal to 5, and taxes sausage consumption about 10 kilograms per week at 1 pound per kilogram. So tax of X is equal to 1 pound if X is greater or equal to 10. Draw the household budget sets. Okay. Right. So, Drew, what is your thinking on this? How would you go about this? Let's start with the first one where there's no taxation. So let's start with no taxation.
Yeah. So I did. So it was 4x1 plus 2x2 less than or equal to 100.
Less than or equal to 100, right? That's going to be the budget set. If you wanted to do just the budget constraint, you would simply equalize those two, right? James, how would you quickly find the intercept? Let's say this is the X, this is the Y. So X we said was sausages, and Y as we said is potatoes.
Just do it back to naught.
Say it again?
Put X equals naught and then...
Yeah, put X is equal to naught, or the way I like to think about it is if I spend all my income on Y, right, then this is going to be 100 divided by 2. If I spend all my income on X, this is going to be 100 divided by 4, right? So it's going to look something like this, okay? Sam, what will happen now when we have this taxation? How would things change?
So it's saying that if there's more than basically 10 sausages, the price of sausages is going to go up by £1 per sausage, basically.
Correct.
So it's going to be a new line from 10 on the x-axis. So it's going to diverge at that point.
Exactly. So if this is 25, if we think of this as 10, right, the price of sausages will change. Okay. Absolutely. What else will change in there? Angus, what else will change?
The potatoes function.
Yeah.
Exactly. Right. So you're gonna get 5 kg of potatoes regardless of anything, right? So, Drew, how do you show that you're gonna have 5 kg of potatoes regardless of what happens?
I kind of like shifted it up. So you have 3 no matter what. So sorry, 5. So the whole budget line would move up by 5.
Okay. and then if you think about that, if this is 5, okay,
Yeah.
and the 5 that you're kind of looking for, what you know is that at this stage you're going to get at least those 5 potatoes, right? So 5 potato will always be part of your consumption, right? So let's say that you only want to get sausages, okay? So you want to spend all your money on sausages, for example, right? So let's think about that. So Angus, if you want to spend all your money on sausages, what is the maximum amount of sausages you can buy?
22.
22. How did you find that?
So I worked out the number of sausages you can buy pre-tax and how much of that income you make up, and then I took into account the tax.
Exactly. So if you think about the first 10 kilograms, right, of sausages, they're going to cost you £40. Okay, they're going to buy 10 kilograms. Then you have another 60 kilograms, and those are going to cost 5. Is that right?
Yeah.
So I divide this by 5, and this is going to be 12. So in total, I'm going to have 22. Okay? So this budget will have to start at somewhere like 22. Okay. If I consume 22 sausages, meaning I spend all my income on sausages, how many potatoes can I consume? 5. So that's true, rather than thinking of that as a shifting, because if you're shifting, you're changing both intercepts, right? You're going to have to think of a kink there, okay? So you're going to have to think that it doesn't matter if I spend all my money on sausages, I'm still going to be able to afford 5 units of potatoes. Okay, and then what's going to happen? You're going to have a slope that will tell you the price of sausages up until when?
10.
Up until 10, and then you're going to have another slope that tells you the price of sausages. What's happening to the price of sausages at 10? It's getting more expensive or cheaper?
Which way are you going?
I'm going this way, so I'm going from 22 all the way to 0. It gets cheaper. Drew, what would that mean in terms of the slope? What should happen to the slope? Should it get flatter or steeper?
Gets cheaper. So if sausages get cheaper, then
and it's on the x-axis.
Sausages cheaper, you need.
Is it flatter or is it shallower? Sorry, flatter or steeper?
If sausages are cheaper, then you need more.
If sausages are cheaper, then that means that you will have to sacrifice less potatoes for 1 unit of sausage, so it should become flatter. Okay, so that thing should become flatter when things get cheaper. So basically, you will have sort of like a flatter slope there, right? Initially they're more expensive, so there's going to be a slope that is steeper than the original one, and then you're going to get something that, well, think of this as being steeper. This bit here should be steeper. Steeper, and then it should be flatter. Okay, and then it should be flatter. Of course, what else do I need to do here, James, to really confirm myself that I've drawn this correctly?
Mark on the points where it hits the axis.
Yeah, mark on the points that hits the axis, figure out the kinks, whether the kink is above or the kinks is below, right? So that you really get to a graph that really fulfills what you're kind of looking for. Let's quickly look at the drawings here. So you can tell here that
They've done it the other way around.
They've drawn it the other way around, right? So they've done sort of like sausages here and potatoes here, okay? And these are the this bit here is just with free potatoes with no. This one here is free potatoes with no taxation. So what's happening is exactly, roughly what you said there, Drew. There's going to be like a parallel shift in the budget, but of course you cannot afford more sausages, right? So this parallel shift happens, but only expands your potatoes, doesn't expand your sausages, okay? And then we have the second bit, right? And we can see that the kink, right here, it's the other way around. It's the other way around, so this is the one that's happening with. And then same slope as the one before. So a helpful tip here, if you look at this solution, is to first start with the budget constraint with just the free potatoes, okay? Just the free potatoes and no taxation. And then think of the budget constraint with this extra taxation, okay? Because ultimately at the very bottom here, they need to be exactly the same, okay? So they need to be superimposed to each other. Okay, good. Everybody happy with that? Yeah? Okay, let's see if we can do question 2. Which... Okay, so this should be rather straightforward. Let's take each of you one answer. Angus, I like Coke and Pepsi. I don't care which I drink. I can't tell them apart.
Okay, so the marginal utility gain from both is the same.
Yeah.
So as you can define MRS as like the marginal utility of one over the negative marginal utility of one over the other. It's just going to equal, the MRS is just going to equal -1. So
Exactly.
a line is going to be straight.
Exactly. It's not just important that you draw straight lines. It's also very important that you draw straight lines with a slope of -1. Okay? And, perhaps I could give you a little bit of feedback already here, Sam. Like, you got the right ones, right? But quite often you just kind of gave the indifference curve without any explanation. For example, I would not do that on the exam, right? Yeah. So, Angus, on the other hand, you drew the graphs right, and you made sure you provided some explanations for that, right? So I would definitely try, in a question like this, make sure that you're giving the explanation, okay? Right. James, how'd you do B?
I drew it as an upward sloping straight line again, or, well, it doesn't have to be a straight line, but...
Exactly.
But I just assumed that sort of like love equals hate, but you don't have to do that.
Exactly, yeah.
But yeah, you said that the marginal utility of Pepsi is now negative, so if you consume more Pepsi, you have to consume more Coke to compensate.
Perfect. So, exactly. And exactly what you said there, it's perfect on an exam condition. Because what you want to do is exactly what James did there. He said, I know that it's going to be a positive slope of my indifference curve, and I know that linearity is one option, but it doesn't have to be that, right? Linearity doesn't have to be the way we're gonna deal with that, and that would have been perfect. That would have been a really, really good answer. Drew, how would you do this? I love Pepsi, but I have no feelings about Coke.
For this one, I did a straight vertical line, and why I did that is I said,
think about the way I've labeled the x's. Would you still do a vertical line?
Oh no, yeah, sorry. It'll be horizontal.
It'll be horizontal.
Because so I said if Coke increases, Pepsi would stay the same because you don't care about how much Coke you have; it provides no utility.
Exactly.
So the marginal utility of Coke would be 0, and then so the MRS would be infinity.
Yes, perfect. Yeah, that's exactly one way to kind of argue that, right? And for this one, you would know that it would be straight lines, okay? Imagine that I go back to sort of like James' comments, and I told Sam that I love Coke, but I hate Pepsi, and the more Pepsi I have, the bigger is the impact that I get in terms of disproportionate on a per unit basis, how would you have drawn those in different curves?
So with B?
Let's say that we did B again,
Yeah.
but we did it slightly different. Now I gave you a little bit more about about my hate for Pepsi. Here I haven't defined the hate for Pepsi.
Then you'd the more Pepsi that you had, the more Coke you'd need to compensate.
Mm-hmm.
So instead of just being a straight line, it would be like this.
Excellent. Yeah, more Coke, right?
Even more Coke, need more Coke per Pepsi.
Exactly.
Exactly.
So if you think about this bit here, and I drew it with the same kind of, well, let's draw it with this color here, right? If you hated it more, you could think of something that kind of looks like this, right?
Yeah.
So for the same amount of Pepsi, you would be requiring more Coke.
Yeah.
Okay, and that's how that would have looked like. So it could have looked that way as well. Okay, so if I was making an exam and I wanted to kind of give you a bit of an alternative on that, I could think of something that looks like this. Okay. Angus, how would you do D?
It would be like the perfectly complementary goods.
Yeah.
So it's like a right angle.
Yes. Exactly. It would be a right angle. Where would be the kink of the right angle, Drew? Where would be the kink of the right angle?
The corner bit.
Yeah. Or what do you know about the corner bit? Do you know anything about it?
That's when, isn't that the point where, like, that's the ideal point. That's where they don't need any more milk or coffee. Milk or coffee, yeah.
Careful on the wording. The ideal point will definitely depend on the budget constraint. Okay. So if you think of it that way, it looks like there is infinitely many ideal points. Right?
Okay.
So if you think of this as kind of linking these two together, can anyone come up with or do you want to give it one more try just to think about like what should those points be representing?
The maximum utility from a combination of milk and coffee.
Keep in mind that you can't have maximum utility because there are infinitely many points there, right? Like, so you want some sort of like a different explanation.
You said those points are like almost how much milk she puts in each cup of coffee. So like the ratio of milk to coffee, like she'd normally put in it.
The ratio of milk and coffee having no waste.
Yeah.
Okay, so that's the ideal sort of. Think of this as like a no waste condition, guys. No waste condition, where it's going to give you the sort of like the ideal ratio, or the no waste ratio, where you don't get more of something. Okay. Did this question tell you anything about that? No, it didn't. Right? But as I draw this question, as I draw this ratio, I want to make sure that that this passes through the origin, okay? Because it says I never have them on their own, right? So you always consume them together, okay? So it should be a line that should pass through the origin, okay? So if you look at the way you've drawn it there, right? Like it wouldn't pass through the origin, so it would give you a sense that perhaps I might not want to. Okay, E was an interesting one. James, can you think out loud of E?
Well, yeah, we sort of debated on that for quite a long time because, I mean, we came up with this in the end, but because we just thought you like them both. So again, if we assume that they have the same marginal utility, then it will be sort of similar to the first one, except you don't want too much of, so like too much coffee is bad, and the same goes with tea.
Yeah.
So we sort of like cut it off before the end, because we thought like above this point, obviously like we don't know how much like the values are.
Yeah.
We don't know like what they're, but yeah, we thought like if you increase T, then.
But let me try and take it from where you kind of drawn over there. You've kind of drawn a downward sloping line. Is that right?
Yeah, but
okay.
like not touching the.
But not touching the axis.
Yeah.
But even though I don't touch the axis, it looks like here I'm having, let's say this is tea, and this is coffee, it seems like here I'm having a lot of tea, and here I'm having relatively a lot of coffee.
It's got the same utility.
But it's got the same utility. But it seems like I like tea and coffee, okay? I like tea and coffee, but too much of either stops me sleeping. So, can you think of some sort of ideal level of coffee and tea, right? Ideal level of coffee and tea, but that too much of each stops me from sleeping.
Is it too much of each, like collectively?
Collectively.
Like, oh, it's
collectively, right? Yeah, collectively. Yeah.
We thought we interpreted it as too much of either one.
Yeah, collectively. Yeah.
Okay.
Because in this world, right, the consumer does both good A and good, doesn't consume one or the other. See if you can really think about it. Let me give you like a minute. Think of it individually for a second, and let's hear from everybody what your thoughts are on that. Because this was probably the more difficult one out of all of those. I like tea and coffee, so I'm going to consume both of them, but too much of either, right, collectively, stops me from sleeping. So you can infer from this that there is some ideal level of coffee and tea that you want collectively, right? Collectively. And then you'd like to, anyone?
There'd not be just like a normal curve going to each asymptote still.
Think of it as so you think maybe it's a normal curve like this, okay?
Yeah. Because that shows like a minimum, and there's a minimum amount of tea and coffee, which still gets to the same utility as drinking more of each. I like either of each. So if you're drinking the minimum amount, which gets to the same utility.
What are the two tensions here that are happening at any point in time? You have to think that there is an ideal point, okay? So the way I would actually approach this is by first starting with an ideal point, okay? Think of this as being an ideal point. Ideal tea-coffee combination. Okay. Now, let's compare these 2 points here. Let's say that we compare this point here and this point here.
If you gain utility,
she gains utility when I go from point A to B. She gains utility because of what?
She's got
More tea and more
At the same
coffee.
time, she's got too much. Almost.
But at the same time, she's got a bit too much. So you have this tension between liking more tea and coffee, but also losing sleep because of having more tea and coffee. Okay, so in that sense, you could think of this outcome here and this outcome here as being similar. Okay. What about this outcome here, C, and this outcome here, D?
We've already said they're the same because she likes tea as just as much as she likes coffee.
Yeah.
And any point along that line, she's going to have the same total amount of both.
Exactly, right? In those things, she's going to have the total amount of both, okay? And if you follow this reasoning, you can kind of think of circles where the utility increases as we go closer to the ideal point. This is the tough one, okay? And the thing that you had to balance that were these two tensions, right? The thing you had to balance there was exactly this two tension. I like more, right? But it comes with a trade-off that it leaves without sleep. And if you could figure out that A and B could, at some point, I could find some A and B such that I am indifferent between them because of this tension, and I can find a D and C because of exactly what you started you off at the beginning, right? At the beginning, we said that D and C will have roughly the same kind of amount. Then you'd have come up with this.
With this, why would A and B still have the same utility? Wouldn't it follow logic, like just thinking of like MRS in general, that B would have a preference to A in utility wise?
Why do you think that? They're in the same difference curve. So on one hand, you're getting more tea and coffee, so you're getting some satisfaction out of that.
Yeah.
Okay. But on the other hand, you're losing like 1 or 2 hours of sleep. And that 1 or 2 hours of sleep that you're losing is entirely being compensated by the fact that you have more coffee and tea.
So it's resting on the assumption that like the utility lost from like sleep is equal
to the utility
tea
gain from more tea and coffee.
Right.
Of course, just as James commented out at the beginning, this is not the only way, right? Because we haven't really described exactly what this trade-off is, right? But it seems like that would be a nice way to start off with.
Even if, say, it wasn't exact, wouldn't it just make an oval instead of a circle?
Yeah, you could do that, right? An oval could have, or it could have been a squiggly circle, if you like, right? It didn't have to be. Okay. Okay. So far, so good. 3. Can't tell the difference. What is the marginal rate of substitution between the two?
-1.
-1. £6 to spend on coffee this week. Kenyan's coffee cost £1.50. Colombian coffee cost £1 per cup. Draw a budget constraint in the same diagram and find our optimal consumption bundle without doing any maths. Drew, what would be our optimal consumption bundle? Without doing any maths whatsoever. Like, how could you argue it without doing any maths?
I got 6.
Yeah.
That's just because Colombian coffee costs £1, and then you've got £6 to spend if you don't do any.
Yeah, but you have one more reasoning to make. One more line of reasoning.
Colombian coffee is cheaper than Kenyan coffee.
Perfect. The MRS is equal to 1, meaning I don't distinguish between the two.
Okay.
Colombian coffee is cheaper, so I spend all my money on Colombian coffee. I have £6, so all those £6 will go into Colombian coffee. I don't need to draw that budget constraint. Right? It should be relatively straightforward. Okay. Now, Sam, when it says draw Sabine's demand curve for Colombian coffee, what do you think you will have on the y-axis and what will you have on the x-axis?
Price on the y, quantity on the x.
Excellent. When you say draw demand for Colombian coffee, what are we assuming about Kenyan's coffee price?
It's staying the same.
Exactly. So we're doing this if there is parity. Right? So given that, how would you draw this Colombian coffee demand?
I said if the price is over £1.50, essentially the demand's going to be 0.
Excellent.
So it crosses the axis there. And then you also now know that...
what if the price is 1.5?
Then I said she'd get 4. Because the thing is, if it's £1.49, she would get 4. So I just...
But doesn't have the assumption that she prefers Colombian coffee to Kenyan?
Yeah, so at £1.50, she's
She's
indifferent, so I wasn't sure.
So you draw a flat.
Yeah.
Right?
And then I said, so you know that when the quantities, when the price is £1, she'll get 6, because we figured that out in the last one.
Mm-hmm.
And then I don't know why I put it should just slope all the way down. I don't know why I limited the.
Okay, it should slope all the way down. Let's think about this for a second, because this was something that was a bit of a problem.
Yeah.
Can you all think about it for just one quick minute? Can you come up with a mathematical function for this? What is the mathematical function? The mathematical function. Think about it for a minute. It's easier than you think. It's easier than you think. If price is less than 150, what is your quantity demanded as a function of the price? Or what is the price as a function of the quantity? Anyone got it? Let me know. Here you have it, sir.
Yeah.
How would that function look like?
P equals 6.
Over Q.
Yeah.
How would that function look like if you were to draw it?
Mm,
Certainly wouldn't be a straight line.
no, it would be 6. P.
If P is equal to 1, Q is equal to 6. Okay, so Sam has made a bit of progress there. Sam realized
the curve is going to be.
Sam realized that said, okay, well, I know that Q will simply be equal to my income, which is 6, divided by price. Or if you want, price will equal to 6 divided by Q. So really, you have to graph a function that looks like y is equal to 6 divided by x. Right? Of course, we're imposing the assumption that p is less than 1.5. Okay? So we're going to look at this bit of the graph here. Okay? It's easy if you don't know how it's going to look like to just do differentiation and see what's going to be the slopes of those things to figure it out, right? What's going to be the slope of it, negative or positive, if you take the derivative of this with respect to x?
Negative.
Negative. Okay, so we want a negative sloping line. Which one is negative, Sam? The blue one or the green one?
The blue one.
Blue one is negative. Green one is also negative.
Yeah.
Okay.
Negative,
So
yeah.
you're not going to be able to distinguish between the two then.
Yeah.
Okay. So we need a second one. We need a second order derivative.
Yeah.
What's the second order derivative? So if I do the derivative of this, it's going to be
That shows you if the gradient's increasing or decreasing.
exactly. It's going to be plus 2/6 over x cubed.
Yes.
So it's going to be positive.
So
Think
it's
of a positive face, right? So it's going to be that green one.
Just getting more positive, yeah.
Positive face. That's the green line. Of course, you could have said about what's happening to this as q tends to infinity. Price goes to 0.
Yeah.
Right? So this would look something like this, with an asymptote at 0.
Yeah.
So be mindful when you have things like this. So what's the lesson from here? Don't assume that everything's going to be linear, right?
Yeah.
And if you'd intuitively thought about it, as price was going close to 0, you would spend all your income onto that particular good. The quantity that you could afford would explode to infinity. So you didn't have to stop the quantity at 6.
Yeah.
Okay? Didn't have to stop the quantity at 6. Okay. See if you can do this question. Utility of xy is equal to x squared plus y squared. Px is equal to py is equal to 1. M is equal to 100. A, draw indifference curves. A2, which, if any, of the assumptions of the standard assumptions do these indifference curve not satisfy? B, find the optimal level of consumption. See if you can do this. Do it individually. I just want to come around and get a sense of like how you approach this. x-axis. See if you can draw the functional form of this. Draw the functional form of the indifference curve. Basically, if you apply to the indifference curve is x squared plus y squared is equal to some constant c. If you rearrange everything, you will have an expression of y as a function of x. Agree? That's going to be that functional form where you've done it x and y. So rearrange it x on one side, everything else on the other. You'll have the functional form of that indifference curve. See if the way you've drawn it matches that expectation or matches that drawing.
I'm kind of
Stuck. I'll come to you in a second.
I'm just had a blank.
So let's start with the drawing, okay? Like, you have something like x squared plus y squared equal to some constant.
It's like a circle.
Yeah.
Yeah.
Exactly.
Yeah.
So you have the answer. If this is the equation.
I didn't think I was meant to start with the drawing. Oh, okay. Oh, yeah, and then that's just 10 and 10 because
Yeah.
it's 100. Oh. Oh. Yeah. I don't know what I was trying to do there.
And then you have a budget constraint. So see, like here you were trying to kind of go with the MRS stuff,
Yeah.
which is actually not a bad way if you're sure that the standard assumptions hold.
Okay.
But in here they won't hold, so you're not going to be able to do that. Okay, let's kind of discuss this together very briefly. Sam, do you tell us how you did that?
So I just sort of tried to do it like intuitively almost.
Yeah.
Because basically, utility is increasing. Is when x squared equals plus y squared.
Mhm.
So, and like the increase, like in say the increase in x from like 99 to 100 is a lot bigger than like the increase in x from like 50 to 51.
Absolutely. Yeah.
So it therefore follows that like it's gonna.
So
I
you
don't
said
know
the
how to put
increase in
words.
1 unit of x, okay, is higher when you go from 99 to 100 or from 9 to 10 than when you go from 5 to 6.
Yeah.
Okay. Which means that there's going to be some increasing returns to scale effectively, quote unquote, of owning this x. That could be one way of doing it, okay? Another way of doing it, which I highly recommend, whenever you see an equation that looks like this, you should think equation of a circle, okay? What if you see something that looks like this? A squared plus y minus b squared equal to a constant. What should you think about?
It's a circle with the origin at AB.
AB, exactly, right? It's a circle with the origin at AB. So the moment you realize that this is a circle,
Yeah, you could say k is x.
you know this is 10, this is 10, it could be one of the indifference curve. You know the budget constraint is 45-degree lines that links these two together. Drew, what you were trying to do there is you were trying to set MRS equal to the price ratio. Had you done that, what you would have found is something like here. You would have really found a minimum.
Okay.
You would have found the combination on that budget constraint that would have given you the least utility. The reason being is that this type of indifference curve does not satisfy the law of diminishing marginal returns. So we can't really use that MRS equal to the relative price ratio. So whenever someone throws a question at you, stop for a second and say, do I recognize this utility function? is it a utility function that I'm comfortable that all the assumptions hold, right? And if you are comfortable that all the assumptions hold, then you can go ahead and do it, okay? But if you're not comfortable that the assumption hold, then use your intuition. The intuition should have very quickly told you that there's going to be two solutions here. Either you buy all x or you buy all y. And those are going to give your maximum one. If you knew what you were doing, you could have done this in 2 minutes. Right? So even if this was an exam condition, you could have done this very quickly, especially if you had seen this before. And that's pretty much that. Okay. So if I very quickly, I mean, I've already kind of told you, just so that you can get a sense of just comments in general, okay? Like, Sam, if I look at your work, for example, right? If this was an exam, what would you tell yourself if you were an examiner?
It's very, not really clear what I'm doing.
Yeah, so provide a bit more explanation onto what you're doing, okay? Think of this work as you're giving this work to your boss, effectively, right?
Yeah.
So your boss wants you to have, like, neat presentation, have a ruler, right? Maybe when you write something like this, provide explanation. So here you need to provide explanation onto this, provide explanation onto this, right? So if, for example, I see this answer like this, or I see an answer where you go, I've written this linearly, but depending on the relationship between love and hate for Pepsi and Coke, it could have been different. That, of course, I would have graded more highly the person who wrote that extra line than someone who just gave me this answer, okay? So it's good to form good habits even from the very start. Yeah. So when you submit this work, think of that as being an exam condition, right? Yeah. So that's what I would like you to try and do. That's sort of like the overarching theme on this. And of course, this part C, we discussed it, that it's just incorrect. It's just incorrect, and we need to kind of think a little bit more broadly about it. Okay, with that in mind, we will stop here. I will see you next week.
Yep.
Thank you very much.
Thank you very much. Yeah.